Yeah, thanks, Matt. And as he said, I think really, my part of the presentation is going to be very much focused on the application of these basically an anomaly detection system within our practical business experience. I think that what Matt has said around the role of an anomaly detection system really being to kind of not only monitor and being able to sift through immense volumes of data, but then also to kind of seamlessly surface the most relevant, most applicable kind of trends and exceptions, and then provide some type of recommendation or actionable step that can be taken to address them is really kind of like the core of what we're hoping to get out of anomaly detection. What we basically have seen a lot of operational wins around thus far. So yeah, just to give like a brief introduction to kind of our data system at Pandora. Obviously, we have a ton of daily active listeners, over 25 million per day, spinning over almost 1 billion songs. We've got a massive digital ad ecosystem. We're the largest publisher of digital audio ads in the U.S. And basically the kind of the point of that introduction is just really to surface that we are like the example of a company and an enterprise that has billions of data points coming in, being tracked and recorded across dozens of systems, dozens of media servers, information coming in from device clients, and then from ad servers. And with that kind of diverse spread of data, you can also imagine there's a very diverse spread of teams and kind of organizational components that kind of really need to have some type of centralized way to kind of monitor data and also derive insights and kind of actionable recommendations from. Really, in terms of what we were getting out of anomaly detection, immediately the core business need is really to detect and resolve important technical issues and do it in as little the time as possible. We're all about reducing the time required to detect issues, and then also to ultimately take the steps necessary to resolve them. So interestingly, just to give a little bit of some context around our past experiences with anomaly detection in a practical context, we actually had an existing in-house anomaly detection system that we were using when I first started at Pandora about 18 months ago, and it was a good system. I mean, it worked to an extent in terms of detecting really obvious and kind of substantially relevant outages and things of that nature, deviations and patterns that we definitely wanted to get surfaced. But as we kind of used it more on like a day-to-day basis from an analytics and engineering perspective, we really found that there were some limitations that we wanted to kind of use as learnings for investing in kind of an improved system. And really, the biggest things are the things that are outlined here. Number one was probably just the frequency of false positives. So that's essentially getting alerts or getting updates around the data that were not immediately either relevant or things that just really didn't reflect, based on our business knowledge and our understanding, real issues or substantial deviations from expected behavior. And I think just from an organizational perspective, I'd like to point out that one of the things that I think is effective from a system perspective is just making sure that the alerts that are getting surfaced and detected are things that are relevant, that people care about, that you're not bombarding whoever the stakeholders or the users are with a lot of kind of spurious alerts and notifications. That usually helps in terms of making the system really effective in terms of the results. Kind of related to that, we get alerts that were not always actionable, meaning that it either wasn't immediately clear what the kind of implication was of the particular reporting. We kind of got reports in isolation. There weren't any real correlation of multiple events into a single incident, so it could be difficult to kind of resolve all these disparate strands into trying to figure out what had actually gone wrong or what had been the deviation. Our detection models, while good, I think initially were more limited. They didn't necessarily capture the full range of like seasonal patterns and variants that we needed to really have a lot of really ironclad reporting, which contributed to the false positives I mentioned. And in terms of an ease of use, the system was a little bit difficult in terms of how to actually integrate news sources. And so really from that experience, we kind of took a few kind of more, again, kind of more like system or organizational type learnings from that. So number one was that we really needed a lot more granularity in terms of the deviations and the data that was being monitored. So the example I'd give would be not just looking at like daily impressions or daily impressions within a few substrata, but looking at daily ad impressions with Android users on a specific OS, specific app version, and going into that level of granularity in terms of being able to monitor monitor patterns and trends of data, detect deviations from those trends. Secondly, again, kind of speaking to the false positive point I mentioned earlier, being able to, have a system that allowed some type of, back-end tinkering to kind of customize the monitoring to make sure that we weren't, bombarding people with alerts at an irregular cadence or, alerting people to things that weren't really actionable from a business perspective. The third point was that we really wanted a system that could offer a more holistic picture at an incident level. So basically, taking a bunch of different anomalies that might occur and being able to correlate them into a single incident or set of incidents, so that we could kind of more accurately diagnose the root causes of issues or the underlying causes of broader trends. And finally, just again from more of an organizational perspective, we just had a lot of stakeholders that wanted to use and had a lot of applications to use an anomaly detection system, and we needed to have a system that could kind of support both the kind of more real-time system-level monitoring that our engineering teams were really interested in, with kind of the more analytics and data science focused, like product health, longer-term KPI tracking. And so all those learnings kind of informed our decision to eventually start using Anodot. We've started using their software relatively recently. It's been using it since the end of 2017. We're currently using it by a number of teams within our kind of broader analytics engineering org, our infrastructure engineers, our client engineers, and our product analytics and data science teams. So obviously, we're still kind of working on, really fully embracing it and fully rolling it out to all of the aspects of our systems that we'd want to monitor. But so far, there's been some pretty clear operational wins from our perspective in terms of, again, the core business needs of just reducing the time required to identify and respond to issues. So in terms of how we're using it now, really, and how we're kind of viewing anomaly detection, there's really three kind of main use cases in terms of what we're getting out of it. So the one I'm going to focus on the most for the purposes of this presentation is the first one, which I'm kind of just defining as system operations and health. So that would be your type of real-time or quasi-real-time monitoring of all of our media systems or ad serving, all the things that we'd want to basically have a real ironclad set of safeguards around making sure that we didn't introduce some problem or that everything was performing at peak performance. The other things that we're starting to roll out as well, and that I think also have definite applications from an anomaly detection perspective, are stats and database issues. So just making sure that our event pipelines are still operating correctly, that we're still ingesting events, and that the kind of metadata and fields that are recorded in those events are internally consistent and consistent with our expectations. And then also, I think on an analytics perspective, doing some kind of medium to long-term monitoring of ad and feature performance as well. And those are things that we're working on, actively, kind of adopting more integration with the anomaly system. But for the purpose of this presentation, I'm going to focus mostly on the first use case. And some examples of these kind of, really core metrics that we want to make sure that we have really rigorous monitoring around would be things like, the health of our media servers, whether or not, we're experiencing outages in our ability to play content to listeners. Fail rate for APIs and other kind of measures of, client usage of the app, ad errors, really just, the things at the highest level that would result in a poor quality of service if things went wrong, or alternatively, would be, really good operational wins if we could ensure they were well maintained and functioning correctly. As you can imagine, the short-term, business impact of any, outages and of these things is extremely high, has a large impact on a lot of our listeners potentially. Therefore, there's a really, high, depending on the exact nature of the issue, there's potentially, high to urgent kind of priority for resolving these issues. And kind of as a result of that importance, we're really operating on a very close real-time or quasi-real-time cadence for ingesting data into Anodot. I think we're about 10 minutes from event occurring to ingestion into Anodot for most of our metrics, and we're, still obviously looking for ways to continue to reduce that. So I'll go through some of the, anomalies that we're detecting. I think it's obviously just worth pointing out that, in a lot of cases, these system issues are, not extremely subtle. And there are obviously cases, like this. This is an example, from a week ago where we were, had some issues on our back end with our track recommendations that were resulting in a lot of listeners basically not receiving the tracks that were kind of needed to continue playing their sessions. And this is a particular event, basically a playlist end event. I think I just kind of raised this example because obviously, there's one kind of set of use cases that are extremely clear, and you can imagine that some type of dumb kind of our legacy system that just kind of relies on static thresholds for determining an anomaly would, catch this type of thing. And there's definitely, some instances like that. But I think where we really see the value coming from, anomaly detection and things that are based on machine learning and kind of predictive analytics, are cases where require, a lot of contextual awareness. Pandora, given our kind of user base and the listening kind of patterns that exist, there's a lot of, seasonal variance, both, in the long term and also, within a particular week. And therefore, there's a lot of, pretty clear patterns that emerge in terms of expected behavior, expected, a number of events that should be firing. And I think, having a system that is able to really learn those patterns quickly and be able to detect, substantial deviances from those patterns, in a way that maybe wouldn't be immediately surfaced by either, kind of a older, legacy system or a, just like, people monitoring manually is like where we have a lot of our big wins. So this is an example of just, an outage we had on our Sonos integration recently, and kind of one of our internal ad servers basically, determined that there was a, an outage, and we were able to kind of really respond to this quickly, obviously, based on the deviation from the expected trend, given where we were in the day and the, number of users we had and things like that. So yeah, and I think that kind of goes into like the operational wins we're seeing. I mentioned repeatedly, minimizing the impact on, listening and revenue by just ensuring that we have quicker detection of issues as they arise. It's gotten to the point where, our engineers feel like they can really rely on the software as well for as like a safeguard during scaling or updating of infrastructure. So if we're going to be, putting in updates, it's really convenient and easy for them to basically just continue to use the alerts and monitor kind of anything that might be affected by the changes to make sure that we're not introducing any problems as we scale these new processes. And then as well, kind of it also, when issues do arise, it really does save engineers a lot of time and energy in terms of identifying the scope and the source of problems. I think there's a couple things as well from a system perspective that really aid in that last point. I mean, Anodot, for example, supports integration of alerting with our Slack system, and that's something that we found is particularly effective in being able to have engineers own a particular domain area, and they have their internal kind of Slack channel that they use to make sure that everything is to kind of communicate around that particular set of issues, and having alerts getting surfaced right in that context we found is like extremely useful in surfacing the issues to the people who are going to be able to investigate and triage those issues, and really resulting in again, reduced time to respond to these particular types of issues. Another, I think, really, again, this is something that I mentioned earlier, but another really fundamental aspect of what we're getting out of anomaly detection is the granularity. So being able to, again, detect anomalies within, very specific and narrow strata. So you can see here just a few examples of, just kind of the number of like dimensions that we're applying to some of these things, each with a separate time series, each, having this anomaly detection applied to identify deviations. And that, again, just comes back to making the alerts actionable from a business perspective. It's not really enough to know that there's some, issue going on with some really high-level KPI like ad impressions. It's much more immediately relevant and useful to be able to identify, the specific type of platform, the specific cohort of users that are affected, so that we can immediately kind of, go into the diagnostic mode without having to do a lot of preparatory research. And that's something that I think Anodot is like really helping us do. And I think when you kind of combine that granularity of metrics with a way to kind of correlate multiple anomalies into a single incident, that's where we really kind of I think, distill the value of this type of system. So here's an example of, a set of correlated anomalies. You can see that they occurred basically at the same time. They're, two kind of ad server request metrics that we have, and being able to see that, these types of things occurred, simultaneously, contemporaneously, and that they, affected, very different types of ad impressions means that, we can, start to make some conclusions about that just right off the bat. But yeah, it's probably an ad server problem. It's not just a question of ad demand mix changing. Even this type of thing where we can, have these types of incidents correlated and surfaced in a single dashboard really just cuts down on the cognitive load required to, begin to diagnose some of these issues and ultimately work towards a solution. And then just to give a brief, kind of overview of some of the things we also are starting to do from these other two kind of aspects. I've talked a lot about the system and operational health kind of aspect of this. Where our analytics teams are also, actively working to kind of integrate Anodot into their processes. There's a few different use cases that we think are going to have a lot of long-term benefit there. Being able to kind of look at and identify anomalous combinations of values. So that would be basically something as simple as applying this tracking to different data tables and looking at the kind of time series of event counts with multiple kind of combination of values and seeing if there's any different kind of deviations in the frequency of particular event combinations is something that is just really helpful as like a kind of core data quality monitoring. Being able to isolate kind of the impact of experiments and feature releases from the natural kind of variance, I think that's really helpful as well. Just gives us more insight and quicker insight into changes that we might be introducing, and being able to disentangle that from kind of expected behavior due to the time of day or the day of the week and things like that. And I think in the long term, we're also hoping to just make sure that we have this monitoring around our kind of medium and long-term trends for KPIs at a high level, just to make sure that we are able to really have some rigorous safeguards in place around those. So that's just like a really, again, high level and pretty brief overview of like what we're using this type of machine learning based anomaly detection to achieve at Pandora. And you can see just kind of like the multiple facets, the multiple teams that are kind of touched by this, and how it kind of plays into our ultimate business objectives to really just minimize the impact of these things to our listeners.